We are going to learn to compute simple interest. So here are some of the vocabulary words you're going to be hearing. Interest, simple interest, principal, and rate of interest. Let's go over interest and simple interest vocabulary words. When you borrow money from a bank, you pay interest for the use of the bank's money. When you deposit money into a savings account, you are paid interest. Let's talk about that in detail. A bank, when you borrow money from a bank, they're not just going to say, okay, you just pay that amount back and we're square. They're going to charge you for taking out a loan from them. So you're going to end up paying back the amount you borrowed plus interest, extra money. Simple interest is one type of fee paid for the use of money. So they're very similar. Simple interest is just more specific. When you deposit money into a savings account, sometimes you get paid interest. So they might say on this savings account you earn 3% interest. Well, that means the more money you put into the bank, the more money you're getting back because they're going to be paying you to put money into savings account. So this formula has got to be memorized. It is not on your formula chart. I equals PRT. I equals PRT. A student last year kept saying IPERT to remember it. I equals PRT. Let's talk about what each piece means. I is simple interest. This is money. This is an amount. It is not a percent. This is money. It's an amount. It's a dollar amount. Simple interest is. P is principal. Not like the principal of a school. That's different. Principal is the amount of money borrowed or invested. So if you borrow $5,000 from me, the principal amount is $5,000. And I'm going to charge you interest. So I'm going to set a percent of interest that you would pay. I might say you got to pay me back the $5,000 plus 5% interest. Well, that's where the R comes from. Now, the only thing that's not on this slide is this has to be written as a decimal. It has to be written as a decimal. You changed your percents to decimals when we did percent increase decrease. You changed percents to decimals when you were finding percents. You changed percents to decimals whenever you were looking for a number when you had percents. You changed percents to decimals. Just remember that. T is time, that the money is borrowed. This is always in years. Always. If they say that you borrowed for 2 months, you better write 2 out of 12 because 12 is the number of months in a year. Okay? So 2 out of 12 would be years. You've got to write it in years. I is simple interest. P is principal, the amount borrowed. R is the rate of interest. Remember, rates are written like ratios, and those look like fractions, and those can be changed to decimals, to percents. So rate of interest is usually given to you as a percentage. That is your R. T, time that the money is borrowed or invested in years. In years. Not months, not days, years. So here's your example. Finding interest and total payment on a loan. To buy a car, Jessica borrowed $15,000 for 3 years at an annual simple interest rate. Annual means yearly. And that's what annual means, every year. She's going to be charged a simple interest rate of 9%. How much interest will she pay if she pays the entire loan off at the end of the 3rd year? Let me walk you through this. First, you got to find the interest she's going to pay. I equals PRT. I equals, if you're doing interest, I equals PRT. Just because you see a percent does not mean you set up a proportion. If it has to do with interest, you use I equals PRT. I equals, because we don't know the interest. We don't know. It wants us to find it. I equals the principal, which was $15,000. That's what we borrowed. Times the rate, 9%. We changed it to 900 because that's what you do to percents. Times the time, which is 3 years. Principal times rate times time. 15,000 times 9%, 900 times 3. When we multiply all that together, we get 4,050. Let's keep going, though. She's going to pay $4,050 in interest. You can find the total amount, A for amount, to be repaid on a loan by adding the principal to the interest. She's not just going to pay the interest. She can't get away with that. She still has to pay off the $15,000. So we're going to add the principal and the interest, and we get $15,000 plus $4,050. Her total loan amount after 3 years is going to be $19,050 on her loan. So just because she borrowed $15,000 does not mean she pays back $15,000. She also has to pay back the interest. Here's your check it out. Let's see if you can do I equals PRT. I equals PRT. To buy a laptop computer, Elaine borrowed $2,000 for 3 years at an annual simple interest rate of 5%. How much interest will she pay if she pays the entire loan off at the end of the 3rd year? What is the total amount that she will repay? I equals PRT. Go ahead and pause and try this problem. Okay, first, find the interest that she's going to pay using I equals PRT. I equals interest equals principal times rate times time. Interest equals $2,000, because that's what we borrowed. That's our principal. Times the rate of 5%, 500ths, because we always change it to a decimal. Times time in years, 3 years. When you multiply all those together, $300 is the interest. We still need to add it to the principal, so that way we can get our total amount, which is $2,300. So Elaine's going to repay a total of $2,300 on her loan if she pays it off in 3 years, because sometimes you can pay off a loan early. But next example, we're going to be talking about investments now. On a loan, you take out a loan and you think, all right, I took out a $15,000 loan. I have $15,000. When in reality, you do not. You owe $15,000. And you're going to owe even more than that because they charge interest. But on an investment, you put $6,000 into a bond like Nancy did, and you think, oh, I don't have $6,000, but you do. And then you earn extra money on it. So Nancy invested $6,000 in a bond at a yearly rate every year of 3%. She earned $450 in interest. How long was the money invested? So she earned $450. Let's see how long it took her to earn it. I equals PRT, because we're talking about interest. And so this time we know the interest. We know the interest now, so we're going to put $450 in for I. Now we have the I. Great. We also know the principal. That's the amount she invested, which was $6,000. And we also know the rate, which was 3%. So we move the decimal places 2 to the left, and we get 300ths. But we don't know how much time it took her. Let's work this out. 6,000 times 300ths is 180. So your equation now is 450 equals 180t. Look familiar? Absolutely. This is multiplication, 180 times t, because they're together. When they're together like that, that's multiplication. Inverse of multiplication is division. We divide and we get 2.5. She invested the money for 2.5 years and earned up $450 on it. It's pretty good. So you could also say 2 years and 6 months, because half of a year is 6 months. Here's your check it out. TJ invested $4,000 in a bond at a yearly rate of 2%. He earned $200 in interest. How long was the money invested? Press pause and try this problem. Okay, I equals PRT. IPERT. I equals PRT. Let's use it. I is interest. We know it. It's $200. The investment was $4,000, and the interest rate was, the yearly rate was 2%, so 200ths, and we don't know the time. So we just plug stuff in. It's just like a surface area formula or a volume formula, or et cetera, et cetera. You just plug it in as you know it. 4,000 times 200ths is 80. So we get 200 equals 80t. Inverse operation is division. And we get 2.5, or 2.5 years, or 2 years and 6 months. Here's another example. John's parents deposited $1,000 into a savings account as a college fund when he was born. How much will John have in his account after 18 years at a yearly simple interest rate of 3.25%? Ooh, interest. I pert. Alright, let's plug stuff in as we know it. Interest. Do we know the money amount of interest? Let's look. He deposited $1,000, 18 years. Interest rate, no we don't. So it's I. Principal, we do know, deposited $1,000. R, rate, as a decimal, 0.0325, and the time in years is 18. So we multiply all of that out, and we get 585, and that's just the interest. So now we need to find the total. We got to add that into what he deposited. So when we add that in, we get 1585. So John will have $1,585 in his account after 18 years. Here's your check it out. Bertha deposited $1,000 into a retirement account when she was 18. How much will Bertha have in this account after 50 years at a yearly simple interest rate of 7.5%? Press pause and try this problem. Alright, so I see the word interest. I think I pert. I equals PRT. Let's plug stuff in as we know it. We don't know the interest. We do know the principal, though. She deposited $1,000. Oh, we know the rate. It's 7.5%. Change it to a decimal. And we know how much she invested in years. Yes, we do. It's 50. So plug that in, multiply. You get 3,750. So now let's find the total. Because remember, that's just interest. We got to add that into what she deposited. So principal plus interest, and we get 4,750. So Bertha will have $4,750 in the account after 50 years. I promise this is your last set. You got to remember there's 4 variables, so we got to solve it all 4 different ways. Mr. Johnson borrowed $8,000 for 4 years to make home improvements. If he repaid a total of $10,320, at what interest rate did he borrow the money? P plus I equals A. So you have to remember that if he repaid a total of $10,320, and we know that he borrowed $8,000, we got to find I. We have got to find the interest that he paid. We know what he borrowed. We know what he ended up paying in the end. And now we got to find I. Inverse operations. That's a positive 8,000. So we subtract 8,000 and we get 2,320. That's the amount of interest he paid. Fantastic. Now we have I. So we can plug stuff in. I pert. $2,320 was what we found in the interest. He borrowed $8,000. We don't know the rate, obviously, because the question said, what's the rate? And time, his investment was for 4 years. Let's do 8,000 times 4. I know they're not next to each other, but we can multiply those. 32,000, R, and inverse operations. That's multiplication, divide. And you get 0.0725, but remember, rate needs to be in a percentage. So let's move that decimal 2 places right, and you discover, oh, his annual rate was 7.25%, or 7 1/4, 7 1/4%. Here's your check it out. Let's see how well you can do this. Mr. Moji borrowed $9,000 for 10 years to make home improvements. If he repaid a total of $20,000, he repaid a total, at what interest rate did he borrow the money? Press pause and try this problem on your own. Okay? First thing is, I know I'm going to use IPERT because I see the interest. And I see the P, which is borrowed. I see the years. And I don't see I or A, or R. I know I'm going to solve for R. Oh, I got to find I. So use the principal plus interest equals the total amount. and it'll help you. $9,000 was borrowed, and the interest we don't know. That's what we're looking for. And the total he repaid was $20,000. Let's subtract that 9, and we get $11,000. So he paid $11,000 in interest. That's a lot of money. IPERT. He paid $11,000 in interest. He borrowed $9,000, and that was for 10 years. So we substitute that information into our I equals PRT formula, simple interest formula. 9,000 times 10 is 90,000. Inverse operations, divide by 90,000. Drop off those zeros, please. Balance them out, one on top, one on bottom. Chop them out. 0.122 repeating for the R. Move the decimal, please, because rate is written as a percent. So, Mr. Emoji borrowed the money at an annual rate of about 12.2%. We say about because that 2 repeats, so we could never be exact. Well, good job on your check it outs. If you need to rewind the video to go over any piece of information, do so, or you can move on.